Hello, today we will be discussing how to fit rheology data from a temperature ramp with the Vogel-Fulcher-Taman VFT equation. This equation is useful for various physical parameters such as viscosity data, but can also be fitted with ionic conductivity data as well.
So the Vogel-Fulcher-Taman VFT function is widely used to describe the temperature dependence of dynamic processes in material science and condensed matter physics, particularly in relation to viscosity and relaxation phenomena. One of its key applications is in modelling the viscosity of liquids, where it captures the dramatic increase in viscosity as the material approaches the glass transition temperature, Tg. This behaviour is critical for understanding the flow properties of polymers and glass-forming liquids. Additionally, the VFT equation is essential in studying relaxation dynamics in polymers and glasses, and it describes the temperature-dependent relaxation times, denoted as tau, of amorphous materials. The VFT function plays a significant role in ion transport studies, where it explains the temperature dependence of ionic conductivity in systems such as solid polymer electrolytes and polymer-based capacitors. Its ability to model these thermally activated processes makes it valuable for optimizing electrolyte formulations and enhancing the performance of energy storage materials. In my work, I fit viscosity data to VFT equations to describe the exponential thermal thinning of viscosity of the electrolytes I work with. So to start off, we will put all of our data into an origin table. So you can see here we've got 4 different sets of data. We've made sure that temperature is set as the x-axis for all of these 4 different sets of data. We've ensured that y is set for the viscosity, and we've ensured that we've labelled each of our different samples. So temperature can be in degrees Celsius or degrees Kelvin. The only thing that you have to make sure of is that the temperature unit is consistent between your samples. So this was measured in Celsius, but then was converted to Kelvin in an Excel spreadsheet. So to do a VFT fit, we select the X and Y column for a single data set. We then go into analysis, fitting, nonlinear curve fit, and we open the dialog box here. Once the dialog box fit pops up, we go down to rheology functions and we select VFT and you click fit. You'll notice that new fitting tables will show up here. It is quite easy to get confused with which of these tables are related to which columns of data. So what I normally do is I normally work left to right and I label these tables as I go, because if you don't, then it can be quite confusing and difficult to work out what functions are related to which table of data. So if we then were to plot this, so I mean I can show you again, basically I can do all of this data that we're going to fit it with a VFT function. We'll just click yes. We'll go back here and relabel that. So I've got my screen sharing box over the data there. So you can see this doesn't really take very long once you've got everything set up and in the right place. And we'll just label this final sample. So now if we want to plot all this data, we then open this in, I want to plot the initial data as a scatter plot to show the data points. I'll change these to being, I'll first bring in the VFT plots. So we do this by adding in the VFT curve, and if you just hold down Control, you can select multiple here. The VFT fit curve of each one here, and you can see we've done it for 4 different samples, and there's 4 different curves, and we bring them over onto the plot, and we apply, and we'll see the lines pop up here. I might just bring this. Firstly, I'll put a frame around the graph so it looks nice and pretty. I'll drag this box over here so it's within there. I'll remove the frame from the legend. And there's just a little bit of tidying up here that we need to do to make this just a little bit more attractive.
So after some optimization of the graphing parameters, this is what we finally reached with a beautified graph with correct labeling.
But after you've finished doing some beautifying of this graph, then you can go back to your table, and there's important parts in this first table for each function, and this is where labeling this comes in handy. So I've already copied what's important from this one, but if I go across to this G4 sample here, the important values in relation to the VFT function are right here. So what you do is you copy this just with a Control-C, and we will copy this into a Excel spreadsheet, and we'll just delete that because the R squared needs to come across to here, and I will just make this all the same formatting. But basically, the important values for your VFT are right there in that, in this plot here. So the viscosity, the standard error, the B value, and the T0 or X0 value, and the standard deviation, standard error, and then if I can drag this over a tad here, then you can see the R squared value that's important here. So the only thing that is left is how you describe this function, and you can check out, I'll put a link to the DOIs of one of my papers where I've discussed fitting of viscosity data to this function, and basically you include this equation in here to describe what the different parameters are and aspects of the VFT function. Thanks for watching. Please like and subscribe and comment if you would like any future videos.